All right, we're going to look at the first practice example. We do it together. I do a little, you do a little. So the practice example is for number 1. This is the Hermes one, so let's read through it. So a messenger is sent by a courier named Hermes from Athens to Olympus. Hermes travels at a constant speed of 6 meters per second. Constant speed, my acceleration is 0 for Hermes. Surprisingly, 3 minutes after the message has been sent, a catastrophic error is found. How fast will the second courier have to travel to catch Hermes before he gets to Olympus? Oops, I missed a sentence in there. Olympus is 3.4 kilometers from Athens. So here's Athens, Hermes leaves it, and a little bit later, a second courier has to run to catch up to Hermes before he delivers the errored message to Olympus, which is 3.4 kilometers or 3,400 meters away. So I have to do that conversion. Also, he has a 3-minute head start, which is 180 seconds. So if you would, go ahead and put a star next to this one and write start at different times. So this is where you're going to see our example on how do we deal with these ones that start at different times. All right. So what this looks like graphically, in case you're curious, is here at t equals 0, we have the time at which Hermes has left, and he's leaving, and then 3 minutes later, a second one leaves and heads up to catch him. And the last moment they can catch him is at Olympus. So that's our goal. We don't want to tire him out too much. We just want him to get there at the last possible moment so he can run this speed or faster. All right, so let's go ahead and set this up. So we have 2 objects, so we have a simultaneous problem. Both Hermes and the courier are going to start at Athens, which I'm going to call 0 meters, and they're going to end at Olympus, which is 3,400 meters away. Now they are both traveling at constant speeds, meaning my velocity initial and my velocity final will be the same because my acceleration is 0. And whenever you have an acceleration of 0, you can use equation number 2. So I have x is equal to x naught plus v naught t plus 1/2 at squared. Now Hermes' velocity was 6 meters per second, and the other courier's velocity I'm just going to call v. I don't know what it is, but I do know it's going to be constant because the acceleration is 0 meters per second squared, meaning I'm using equation 2. All right, so let's cross some stuff out that's 0 and see where that leaves us, okay? So I start crossing stuff off that's 0, so that's 0, the acceleration is 0, this is 0, the acceleration is 0. Okay. Now I get to these 2 equations, and this one says x equals 6t. Well, I guess 3,400 equals 6t, and over here I have 3,400 equals v, which is the speed, times t. All right, so I could solve for t here and plug it in over here, and I'd get the same v though. So these t's are different, and that's because Hermes got a head start. So the trick for doing these ones where they start at different times is we choose the shorter time as a time t. And so who's been running for a shorter time? The courier chasing him has been running for a shorter time of t. That means Hermes has been running for a time t plus the 3 minutes or 180 seconds. And so what this allows us to do is it puts them on a common time frame with this common variable t. Okay, so that's what we want to do whenever we run into these situations where they start at different times. So making that substitution here, we now have t plus 180 here, and over here we just have t. So what we're going to do, we'll solve for t over here for Hermes, then plug that t in over here and solve for the velocity of the courier. So we get a time of 386.7 seconds. Let's do that algebra quick for you though. 3,400 divided by 6 is equal to t plus 180, and then we just need to subtract the 180, so 3,400 divided by 6 minus 180 gives me t, which came out to 386.7 seconds. Because we're using this, we do want to store that on our calculators. And plug that in over here, solve for v, and so we find out the speed of the courier is 8.8 meters per second. Remember, when you're doing your homework, you are going to need 4 sig figs. So make sure when you get your answers in your homework, you use all 4 sig figs. But here, I'm just going to round it to 8.8. 8.8, they're sprinting to catch up, but, you know, ancient Greece, you know, you don't want to anger the gods up there in Olympus, so you'll do it. Okay, so that's that one. The next one also, the practice example is kind of similar and it starts at different times. So that one's going to be more of a practice for you. Okay, so next video will show you that though.